and we're going to look at properties of numbers. Now, we use these properties all the time. It's almost second nature, but we just don't remember the names. So there's several different properties that we use, and these are on page 84 at the bottom. We're going to go through each property, and then we're going to show examples of each property. So these are the properties, and this is on page 84. These are all the properties. We've got the commutative property, the associative property, the identity property, the inverse property, and the distributive property. So we're going to go through each one. We're going to talk about what happens with each property. And I'm going to show you an example with addition and also with multiplication for these. So we're first going to look at the commutative property. Again, we'll go through each one of these. And I'll show an example with numbers in multiplication and also addition. When we look at the commutative property, what we're looking at with it is we're specifically looking at order. So when I think of commutative property, I'm going to look at the order. And I can change the order in addition and multiplication. Doesn't work for division, doesn't work for subtraction. Those you have to watch the signs. But for addition and multiplication, we can change the order. Because our property says this. It says A plus B is the same thing as B plus A. And here's an example. 4 plus 5 is the same thing as 5 plus 4. 8 plus 2 is the same thing as 2 plus 8. Okay, so when I talk about the commutative property, what am I allowed to do with the commutative property? Switch the order. Okay, because we know 5 plus 4 is the same thing as 4 plus 5, right? They are the same. We use this property, we just never talk about the name of it. But that's the commutative property. Commutative property says I can switch the order. And these, by the way, are just examples. It also works for multiplication. Because A times B is the same thing as B times A. And we know that's true because 4 times 3 is the same thing as 3 times 4, right? All I did was switch the order. 8 times 2 is the same thing as 2 times 8. So when I talk about the commutative property, what am I really doing? I am only changing the order. That's it. Order. Nothing else, just the order. When I talk about the next one, the associative property, we're looking at changing the groupings, not the order. A lot of times students get confused between the commutative property and the associative property. So the commutative property is all about changing the order. Associative property, we change the grouping. So the next one is going to be the associative property. And that's going to work with the groupings. We're not going to change the order. We only change how they're grouped together. So think about associate, and you associate with someone, you go into groups, okay? You group together. They're your associates, they're people you're close to, so you group together. So we change the groupings, not the order, just the parentheses. So we're going to look at examples of the associative property. Your definition is A plus B with parentheses plus C is the same thing as A plus B plus C with parentheses. I'm not changing the order. All I am changing is the groupings, the parentheses. So here's some examples. 4 plus 3 with parentheses plus 9 is the same thing as saying 4 plus parentheses 3 plus 9. I am not changing the order. The order did not change. What did I change? The groupings, the parentheses. So the associative property is the groupings. Think about associate. Who you associate with, you group together. That's how I remember it. Associative property means how they associate, how they group together. So it works for addition. It also works for multiplication. ABC with parentheses, like this, is the same as A parentheses BC. So all I'm doing with the associative property is changing the groupings, not the order. Order does not change. So about 3 times 2, that's a multiplication dot there, times 4 is going to be the same thing as 3 parentheses 2 times 4, right? They're the same. No matter where the parentheses are, they're the same. These are multiplication dots here. So you can see they're multiplication dots. Okay? So you can change the grouping. So that's the commutative property, order, associative property, groupings. Next, we've got the identity property. And the identity property means the same. And the way I remember the identity property is I think of identical twins. And what do we know about identical twins? They're the same, right? Okay. So when we talk about the identity property, we're going to be doing things that don't change it. There's an additive identity and there's a multiplicative identity. And the additive identity says if I add 0 to something, it doesn't change it. Right? Because 5 plus 0 is still what? 5. It stays the same. Identity means they're the same. When I add 0, it doesn't change it. 8 plus 0 is still what? 8. So adding 0 to something does not change it. We know that. We just never call it the identity property because we just use it all the time. Or you can take 0 and add it to a number. It's still that same number. What about multiplication? Well, if I take a number and I multiply that number by 1, it stays the same. So 8 times 1 is still 8. 9 times 1 is still 9. So there's an additive identity and there's a multiplicative identity. The additive identity is 0. The multiplicative identity spell it right here. Multiplicative identity is 1. So the additive identity is 0. The multiplicative identity is 1. If I add 0 to a number, does that change that number at all? No, it does not. So adding 0 stays the same. If I take a number, any number, no matter what it is, and I multiply that number by 1, it stays the same, doesn't it? So there's an additive identity of 0. It stays the same when I add 0. And there's a multiplicative identity, which is 1. When I take any number and multiply it by 1, it doesn't change. There's an additive identity and a multiplicative identity. Once we go through all the properties, then we'll look at examples, and we're going to try to figure out what property is being used. So we've got 2 more properties, and then we'll look at examples. The next is the inverse. And inverse means opposite. So the inverse is going to mean the opposite. So this is our inverse property. Now the inverse, there's a multiplicative inverse, and there's an additive inverse. So when we talk about the additive inverse, we'll do it first. It goes to 0. So the additive inverse is the opposite. So if I had 5, the additive inverse of 5 is negative 5. If I have negative 8, the additive inverse of negative 8 is positive 8. If I have 12, the additive inverse of 12 is negative 12. So when I talk about inverse, I'm talking about opposite signs. Same number, opposite signs. They go to 0 because they cancel each other out. That's inverse, opposite. The multiplicative inverse is the reciprocal. So the multiplicative inverse is A times 1 over A is 1. So examples of multiplicative inverse would be, make sure you see that's a multiplication dot, would be 8 times 1/8 is 1. 9 times 1/9 is 1. 3/4 times 4/3 is 1. Okay, we're looking at reciprocals. They flip over, and they equal 1. Must equal 1. So inverse is the opposite. So let's talk about the 2 types that we have. The additive inverse what happens with the additive inverse? Opposite signs. Okay, so the additive inverse, we're going to be looking at opposite signs. So when I talk about the additive inverse, I'm just looking at opposite signs. 5 and negative 5, 12 and negative 12, 15 and negative 15. Opposite signs. Those are additive inverses. The multiplicative inverse is the reciprocal. So the multiplicative inverse is the reciprocal. And when we talk about reciprocal, what does that mean? Flip it over. Flip the fraction over. Flip it upside down. One more property, and this is the one that we probably use more than any other, is the distributive property. You've probably heard of this one more than any of the others, because a lot of times we actually use the name when we use the property. So this is our last property here. We're going to look at the distributive property. And the distributive property says A times B plus C is the same thing. You distribute that A through or push it through. Is the same thing as AB plus AC. That's your distributive property. Here's an example. 4 times 3 plus 2 in parentheses is going to be the same thing as 4 times 3 plus 4 times 2. Or 9 with parentheses times 8 plus 10. That would be the same thing if you use your distributive property. That would be the same thing if I distribute through. That's going to be the same thing as 9 times 8 plus 9 times 10. We use the distributive property a lot when we work with variables. So when we work with variables, we use the distributive property a lot. And we're going to be using this a lot more in 1.7. You can also put it in the opposite order. You can also have, we don't use it very often, but it's there if we need to. B plus C out in front with an A behind. You can distribute it through just like this. So you normally don't do this, but you can. And that would be BA plus CA. Okay, so same thing. You can just do it in the opposite order with the A behind. We don't use it very often, but here's an example with numbers. 3 plus 2 with the 5 behind. You can distribute that through. And that would distribute through, and that would be 3 times 5 plus 2 times 5. So the distributive property, we have parentheses and we distribute through. We draw those arrows. So that's the way I remember it. We distribute something through, push it through. Now we're going to look at several of these, and you're going to tell me what property I'm using. So I'm going to mix them up, and you're going to tell me what property I'm using here. How about we look at 4 plus 8 plus 5 is the same thing as, how about 4 plus, in parentheses, 5 plus 8. Okay, so I picked this one to make sure we know the difference between the associative property and the commutative property. All right, now, first off, did I change what was grouped together? No, because on the left-hand side, 8 and 5 are grouped together, right? On the left-hand side, left-hand side, 8 and 5 are grouped together. Right-hand side, same thing. What did I do? I changed the order, right? I changed the order of the 8 and the 5 when I added them together and made that 5 and 8. So this would not be associative. This would be the commutative property. So this would be an example of the commutative property. Because I did not change the grouping. I changed the order. Let's try another one. How about 3x plus a minus 3x equals 0. What property would this be? Well, okay, now when we go back and we look at our properties, which one has the 0 in it? The only one where it equals 0 is what? Inverse, right? 3x, what's the opposite or the inverse of 3x? negative 3x, right? They go together, and they make it what? 0. If it equals 0, this means this is an inverse. If it equals 0, it means it's an inverse. They're opposites of each other. Let's try another one. How about 8x plus 0 equals 8x? Doesn't just have to be numbers. You can have variables in these as well. Well, am I changing it? No, because when I add 0, does that change it? No. The sides are the same, right? Because they add together. 0 doesn't change it at all. So this is your additive inverse. Or additive identity, sorry about that, not inverse. Because when we look at this, the adding 0 doesn't change it. So this would be the identity. Because when we add 0 to something, it does not change it. So that's the identity property. Let's try another one here. What do we think about this one? Does anyone know what this one might be? Okay, I'll give you a hint. It's either the associative property or the commutative property. Which one? It's going to be the commutative property. Why? I don't even have any groupings at all, do I? Right? And when we talk about the commutative property, what am I doing? Changing the order. So 9x plus 3z is going to be the same thing as 3z plus 9x, right? I flipped them around. So this is the commutative property. So that's an example of the commutative property. Let's do another one. What about this one? Well, in this case, did I change the order of the numbers and variables at all? No. What did I do? I just changed where the parentheses were, right? And if I just change where the parentheses are, then that is associative. I grouped them together differently. And we've got one more. We haven't really talked much about the distributive property. But here's an example of the distributive property. Distribute that 4 through. And you distribute through. 4 times 2 is 8x. 4 times 5 is 20. So I distributed that 4 through. This is what we're going to be looking at in this section and the next one in 1.7 as well, is using that distributive property. So I distributed the 4 through. So when I distributed the 4 through, 4 times 2 makes it 8. 4 times 5 makes it 20. That is the distributive property. That's going to be your distributive property there. Distribute or push something through. So now we've looked at all the properties. We've seen examples of all the properties. Now we're going to start using these properties. So now we'll just start working through some of these using the different properties that we have. A lot of this is just something that we automatically do. The distributive one is the one we're going to use more than anything else. Associative and community we use a little bit, but I mean, really don't need to. If you want to, you can group things around. We're going to focus primarily on the distributive property. So let's look at how we use the distributive property. And again, this is 1.6, and we're just going to be using the distributive property. I want us to make sure that we fully understand how to use this distributive property and when we can combine like terms together and when they have to stay separated. So we're going to use the distributive property and we're going to distribute through this 5. So whenever I use the distributive property, I've got the parentheses here and I've got a number out in front. And so I distribute or push through that 5 through each piece. So I'm going to distribute that 5 through. So we multiply 5 by each number inside. So 5 times 3, that makes it 15. We bring down the x. 5 times a negative 2 makes it a negative 10y. 5 times 3 makes it 15. Now, sometimes students look at this and they think you can do more with it. I can't go any further. Why not? To combine like terms together, they have to be the same. This is 15x. Are there any other x's that can go with that 15x? No. So we know that piece is done. That minus 10y, is there any other y's to go with it? No. And that 15 is by itself. So I can't put everything together. Sometimes I've seen students try to combine all of these together and just add all the numbers up. You can't do that. You have to look and see what matches up with the other pieces. And in this case, nothing matches up. So that's all we can do, is distribute that 5 through, and that's it. So that's all you can do with it. If there's a negative out in front, that just switches your signs. So let's again use the distributive property with this one. So we're again using this distributive property. And in this case, I like to circle it because that negative goes through with the 8. So we're going to distribute through or push through a negative 8. So negative 8 gets multiplied by that positive 4. We do each one individually. So negative 8 times positive 4. Negative times positive makes it a negative 32x there. So there's that piece. Next, what's next here? Well, next we have negative 8 times negative 9. And we know negative and negative makes it a what? Positive. And 8 times 9 makes it a 72. And the y comes down. Can I combine these together? No. Very important that we can't. Why not? Because these are different. In 1-7, we're going to learn how we can combine sometimes things together if they have like terms. But in this section, we're not. We're just distributing through. Let's do one with a fraction. Let's do 4/3 times, how about 9x minus 12y. So I want you to use the distributive property on this one. Now, if we have fractions, we're going to distribute it through the exact same way. But we're going to put it over the side if we need to. So if we have trouble working these out, we're just going to put it over the side. So let's work with the first one. We're going to do each piece individually here. So we've got 4/3 first. And we're going to have to multiply that by 9x, and we'll put that over 1. So is everyone okay with what we're doing? So we're taking that 4/3, which is out in front, and we've got to multiply it by 9x. So how do we do that? We make everything a fraction, so we put it over 1. Now what can I do? Well, I'm multiplying, so I can cross cancel. So that 9 and that 3, they can cancel out. And that's going to leave you with a 3 here and a 1. 4 times 3 makes it 12, and the x just comes along with it. And there's a 1 down below, so we don't need to put the 1 there. Because that's just 12 over 1, which is just 12. Do the next piece. 4/3 times a negative 12y over 1. Watch my signs. A single negative keeps it negative. And that 12 and that 3 can cancel out. That's going to leave you with a 4 and a 1. And we know our sign's negative. 4 times 4 is 16. Don't forget your y. So that would then be a minus 16y, right? So don't forget your y. That just comes along with it. 4 times 4 makes it the 16. A single negative keeps it negative there. So that would be your answer on that one. Let's try one more of these, and then we'll learn how to simply distribute a negative through. And that should pretty much finish up this section. So one more of these, and we'll look at how to distribute a negative through. So let's do another fraction one. About 1/9 times, let's say, 81x plus 72. Pretty simple on these. And the fraction ones are going to be easy. They're going to come out to be whole numbers. So the fraction should go away on these. We're going to, again, distribute through. And we can put these over to the side if we need to. We've got 1/9 times an 81x over 1. And we know that the 81 and the 9, well, those can cancel. That's going to leave you with a 9 here. Multiplying across, 9 times 1 makes it a 9. And don't forget about your x. So that's going to come out to be 9x there. Same thing with the 72. 1 over 9 times 72 over 1. 72 and the 9 can cancel. Leaves you with an 8. So that's going to just simply then be an 8. And that's all you can do. So that would be your answer here. Just distribute through. I'll go ahead and box these. These would be your answers. Okay? So you just distribute through. Those are going to be your answers. Now, what happens if there's just a negative? Well, if there is no number out in front and it's just a negative, all it does is change the signs. And just to make sure we've got the same directions as what they use, we're just going to rewrite this without parentheses. So this is the same directions. So we're going to rewrite these without parentheses. So if I have a negative out in front, What does that mean? Okay, so we're going to rewrite this without parentheses. That negative out in front, well, that just means that this negative goes through, all right, and changes the signs. So negatives become positive, positives become negative. So that negative out in front changes the signs, and so that becomes then a minus 4x and a minus 9z. So all I did was I just distributed that negative through. Let's do one more. And then I believe that should then finish up this section. So let's do one more. I'm rewriting these without parentheses. I've got a minus 3x plus 9. Let's use a z squared minus 4z plus 2. Okay, and I picked this one just to kind of give us a preview of what's going to be happening in the next section, when we can combine things together and when we can't. So again, we want to rewrite this without parentheses, so that means this negative goes through each piece, and that changes the signs. So negatives become positives and vice versa. So minus and minus makes it a positive 3x. A negative and a positive makes it a negative 9z squared. Negative and negative makes it a positive 4z. Negative and positive makes it a minus 2. Why can I not combine that minus 9z squared and the 4z together? The reason why those cannot go together is they are different, right? One is squared, one is not. Very, very important that we realize these are different terms. That's what we're going to be covering in the next section in detail. When we can combine things together and when we can't. These are different terms, so they can't go together. So there's nothing else I can do. I'm done. Okay? Resist the urge sometimes to try to do extra things. This is it. This is all you can do. Distribute that negative through and you're done. Do not put anything together. They cannot go together. They are different. So don't try to add the numbers together. You can't. They are different pieces. They do not belong together. And sometimes students struggle with this concept of when to stop. So you would stop here. Don't go any further. You can't go any further because they're all different. We'll go ahead now and take a short break. And we'll meet back at, I'll give you about a 15-minute break. How about we come back at 10:25? So let's meet back here at 10:25.